I'm John Snyder, Harry Simons. I know a lot of people are dealing with time zone changes, so I thought I would try to say something interesting at the beginning. Thought I'd tell a little story. I kind of dug it up yesterday. It's about the ant and the grasshopper. Maybe you've heard this one. So there's this ant that's, they're hard workers by nature. So he's carrying this big piece of corn on his back, getting ready for winter. So he's going along in this field, and this grasshopper kind of calling out to him. He says, "Why don't you put that down, take a break, come over here, and let's chat for a while." And the ant says, No, I can't do that. Got to take this back to the anthill. Got to get ready. Winter's coming. We want to eat. And the grasshopper says, "All right, whatever." And the ant continues on with his business. But later on, of course, when it's winter and food is scarce, the grasshopper looks on, hungry, seeing all the ants distributing their food. So the point that we're going to try to make today is about preparation on your wireless networks. If you take the time now to prepare and put some good security in place, using 802.1x, WPA2 and or WPA2 encryption, I think you'll reap the benefits in a more manageable and secure wireless network. And so we've been trying to do that on our campuses and found some difficulties in interoperability, some protocol issues, vendor issues. So we're going to try to talk about those a little bit and give you a brief overview of 802.1x. So I'm going to introduce Terry. He's going to talk about 802.1x itself and the University of Utah's experiences.
Okay, so I wanted to say thanks for the presentation on the wireless antenna stuff. That's really going to help us out. So 802.1x is relatively young in network term. It's been around since 2001, and that's only 3 years. It's not very well deployed, and for instance, not a lot of hotspots use it. But T-Mobile announced last week that they are planning on providing 802.1x at all of their hotspots, and they hope to have 10,000 hotspots worldwide by the end of the year. So that's good news for those of us that like 802.1x. Some of the issues we're going to talk about include client support. It's sometimes harder for users to use than, say, a captive portal, and vendor implementation problems, particularly with accounting, and also about the changing encryption standards that are coming, such as 802.11i. So the University of Utah is an urban campus with about 28,000 students, and we're very decentralized and scattered. And I'll get into that in a minute here. We initially deployed 802.11b, and there were a lot of different deployments on campus. Some departments did MAC address lockdown for security, and some we did, for instance, my department did a captive portal that we wrote ourselves before there was really any commercial solution available. So my department and engineering, as well as a couple other departments, cut over to 802.1x around May 19th, 2003, so we've been doing it for about a year and a half now. And today we have about 715 APs across like 15 departments that are dedicated to 802.1x. Not all of the departments have actually finished their deployments, but that's something that we're hoping to have done by the end of the year here. And we are doing cross-realm authentications with Radius. So what this means is that a user in engineering can log in, say at the hospital, with their engineering account, and vice versa, so that people can manage local accounts as well as have a centralized user database if people want to use that. And that was something that, with the decentralization, that we really tried to focus on at first, because with the decentralization, everybody wants to manage their own thing, and so that was a big focus. And as was mentioned, I'm one of the developers of the Open1x project. It's an 802.1x supplicant to Linux. Originally, there was some BSD support as well, but that's kind of been not focused on as much. If there are any BSD developers out there that want to help, please let me know. We would definitely like to get you involved. And the Open1x project was originally started by a couple of guys from the University of Maryland. And the University of Utah, we've kind of taken the project over. My supervisor's done most of the work on on everything since probably the original release out of CBS. So. And we are also working on a project called Weep, which is a Windows Heap plugin project. If any of you are familiar with the Secure W2 Alpha RS client, it's something similar to that, focusing more on other protocols that aren't available for Windows, such as EAP-AKA and EAP-SIM. And there is workable code available today. I think the URL for that is weep.sourceforge.net. Okay, some of the challenges that we saw, well, actually I should mention right now, John will mention other challenges, but we saw a lot of the same things. But here, these are some of the other ones. So one of the problems is we really don't have control over any of the users' laptops. So students will come in, they'll have who knows what, no CD-ROM drive sometimes, we have to install a client, that gets difficult. One of the things I would suggest here is if you are deploying 802.1x, specifically in a university environment, and you have a help desk that can do this, USB dongles are very handy, especially for machines that don't have CD-ROM drives. Decentralization makes it extremely hard to standardize anything. Our project's been pretty successful, but it's one of the problems we've been having is the campus policy isn't enforced. It's kind of a, we want you to do this, so please be a good citizen. So that's been pretty difficult. But one of the things that we have done is student task force money that is used to purchase new access points has to support 802.1x, though departments don't have to deploy 802.1x right now. We have, since we're decentralized, we have a lot of different vendors. We don't have really a solid access point list that says, buy these access points, mostly just something that says, you know, we want you to have 802.1x. So that's been a big issue. We have Cisco, Proxim, Foundry, HP, you name it, we've got it. So that's been hard. And one of the, I think the biggest issue we had when we originally deployed was the clients, the Funkin Meeting House client. We have site license for Meeting House. They disable, they install their own Windows Gino, which is basically the graphical login stuff for Windows, and that breaks fast user switching. A lot of people complained about that. And also, they also disabled Windows 0 config wireless networking, which means you have to use the 802.1x client to configure your wireless networks. So that was a problem for a lot of users. And I think John's going to talk about Portland SIGNet.
So we're similar size as far as student count. We're also in the downtown Portland area. And we had deployed it to 11B in sort of public areas on campus originally. This is 802.1x can be our third iteration for wireless security. We started out with MAC address registration, which is horrible, not secure, and doesn't scale. Then we decided to go to a captive portal, which was better, but we still didn't like the fact that users could hop on to the layer 2 broadcast domain without authenticating and use tools like EtherCAT and things to do ARP spoofing and snip people's traffic. We had a lot of problems with denial of service coming from on the network. So we deployed 802.1x using Cisco access points. We have the same issue with students. They buy the cheapest wireless card they can find, they get it off their friend, they move or whatever, so their card may not support any encryption at all. They may be running Windows 95 on their laptop or other unsupported operating systems, so it can be difficult to support them. We also already had this SSID deployed with a captive portal behind it using NoCat. We didn't want to just turn 802.1x on one day, which would effectively have just broken our wireless network for almost every user on campus, because the students wouldn't be able to configure 802.1x that quickly. So what we're doing is we're deploying a second SSID that supports 802.1x. We're going to migrate over to it, and then ultimately cut off the captive portal when people are fully migrated. We are supporting, as far as EAP methods go, TTLS and PEEP. PEEP is the EAP method that is built into the Microsoft client in XP Service Pack 1 and greater. Microsoft only supports MS-CHAP v2 inside of their TLS tunnel that is part of the PEEP exchange. But the Radiator folks have been really great in accommodating the ability to take that EAP MS-CHAP v2 that's tunneled, break it out into a regular Radius access request, and then forward it on to a Radius server so that something like IAS on a Windows Active Directory domain controller can understand it outside of the PEEP context and actually authenticate that way, so we don't have to send all of our users back to a Microsoft Radius server. So we can use Radiator as our main Radius server and only proxy back when we have an MS-CHAP v2 type of authentication coming in. And so the magical command for that, if you're using Radiator 3.9 with the patch and above, is eep peep MS-CHAP convert. And you'll give that the option of 1, and that'll do it. It's really cool. And so a lot of thanks to the Open OSC folks for doing that. But what we're trying to turn most people toward is TTLS with PAP inside. That's a lot better. We don't have these issues, and we'll probably end up using the secure W2 client to deploy that. As far as selecting which type you're going to use, definitely pick a type that supports keying. If you use something like EAP MD5, you're going to have issues because you're not going to be able to generate dynamic keys. So we're suggesting PEEP or TTLS. You can do TLS if you've already got a good PKI deployment. You're comfortable with managing certificates, client certificates for all of your users. It's totally doable and it's very secure. It's just hard in a university environment, but in some corporate settings it might be better. Kind of the differences, PEEP with MS-CHAP v2 inside does a second EAP exchange inside of a TLS tunnel. So you first establish a TLS tunnel with the Radius server via 802.1x frames, and then EAP is done again inside of that with a different EAP type, such as EAP MS-CHAP v2. A man-in-the-middle attack here can result in you getting access to the MS-CHAP v2 hash password. There's also the issue that you have to be able to authenticate these, and so if you're not the Microsoft server with the proper hash, you're trying to authenticate these on a Unix machine or something, you're going to have the plain text password stored there in order to do it. So that's a downside there. Something like EAP TTLS doesn't put a second EAP exchange inside the tunnel. It does the same initial phase of starting up that TLS tunnel with the Radius server, but it does attribute value pairs inside. So it's a little simpler, and you can do something like PAP inside, where you're just moving the clear text password, but it's inside of that encrypted TLS tunnel. So a man-in-the-middle attack can be successful in getting the plain text password. That's why what we're going to talk about next is really important with certificate verification. So Terry's going to talk about that a little bit.
One of the reasons why you might want to use TTLS is if you have to authenticate against a back-end store like Kerberos, where your passwords are strongly encrypted. EAP TTLS is really the only protocol that's widely used today that can do this. One of the other protocols you might want to look at is PEEP GTC, but there aren't a lot of clients that really support that, at least as far as I don't think you have it on Mac OS 10, and I don't think it exists in Linux yet. The WPA Supplicant project might have PEEP GTC. Anyway, certificate verification is a big deal. I've had a lot of students from schools all over send email to the Open1X list saying, my school doesn't have certificates or they don't want us to verify them, and that's a big problem because as soon as you turn that off, you're wide open to man-in-the-middle attack. It's especially a problem, like John said, with TTLS, where you've got PAP inside potentially, but that's something that's not good. So don't turn certificate verification off. Don't tell your users to do it. And as far as certificates go, I would personally recommend that if you can use your own private CA to do that, because it makes things a lot easier to manage. If you purchase a certificate from, say, like Thought or VeriSign, you have to verify the server name, the CN field, off of your server certificate. Whereas if you use your own CA certificate, you can actually say, only allow this, certificates from this CA, where it makes things a little bit easier. So I think that covers all the pieces there. And then also, if you can use a single name on your campus, it might make things easier. You don't have to have individual certificates installed on multiple servers if you have multiple servers. you can use one server certificate. Might make things easier to manage if you want to do like a VeriSign or slot certificate and then verify against a particular name. Okay, the next issue that I'm going to talk about is people, let's see here. Some vendors filter EAP types, which is a big problem. For example, Foundry does it. I know some other ones, I can't think off the top of my head who they are, but this is a really big problem in that if you have a vendor, let's say vendor XYZ, and they filter EAP types, and then down the road they discontinue their product, and then later they decide, and then later, let's say a new RFC comes out or something for EAP ABC. If the vendor's filtering against certain EAP types, then all of a sudden this new EAP type might not work, and there's no reason that it shouldn't. EAP is relatively lightweight on the access point. It doesn't really need to do much. Basically what happens is the access point takes the EAP conversation, extracts the relevant information from the frame and packages it up in a radius conversation and sends it over UDP to the radius server. So it doesn't really get involved with the nuts and bolts of everything, so there's no reason to filter. So, and if you really feel like you have to filter as a vendor, please let us turn it off as a customer. And this issue is actually a pretty interesting one. Some vendors, Cisco, Trapeze Airspace, and a few others, use the peer key to do the encryption. So what that means is when you authenticate, you get keying material back from the access point, which goes to, you get keying material back from the radius server, which goes to the access point, which is then used to determine how to send keys to the user. And the peer key is basically some of the keying material that the radius server sent. Using the peer key on the client means that if the access point sends back a key with no keying material but the correct key length, then the client will use the keying material that was derived during the TLS conversation. So the material is actually derived on both sides, and the client will just start using that. That's bad because if for some reason a hacker ends up being able to crack that first key, they can then derive any key messages that are used later. So we'd like to ask vendors to please, as your first key, please encrypt the key. Please use the peer key to encrypt the first web key. It makes things a little bit more secure. And if anybody has any questions about that in particular, I can go into more detail. Okay, and then one last issue here. Some vendors do not allow the ability to turn off WPA. This has caused issues with migration. Specifically, there's a bug in Mac OS X that doesn't allow association and authentication to access points that are using WPA with WEP as the multicast cipher, which means basically, so it's the ability for cards that don't support WPA to be able to authenticate and use WEP as their keying method, but cards that do support WPA being able to use WPA. So this is basically a problem because if you can't turn it off, then you have the choice of either running pure WPA and letting your Mac OS X users on, or not letting your Mac OS X users on. And if you run in pure WPA mode, older Windows clients won't be able to associate probably. John's going to talk about updates that have happened to WPA.
So just real quick, the 802.11i standard has been ratified, and basically that's using AES and CCNP mode instead of TKIP as the cipher. So the Wi-Fi Alliance is already starting to certify products as compliant under WPA2 certification. For Linux, WPA support is evolving. It is not fully there yet, but it's being worked on and added to wireless extensions version 18. Cisco for sure is planning on having WPA2 support on the 1200 access point with a firmware upgrade before the end of this year. And so if you haven't deployed yet and you're sort of in the testing phase, or you're thinking about deploying 802.1x with WPA, you may just want to sort of wait, depending on your vendor. It's probably imminent that they're going to have an 802.11i firmware that you can use. So you might want to do that. Okay, we've got 5 minutes left, and we have the most important thing left to do, so we're going to get to it. There's some issues with certificate validation. These are things you can easily understand. Laptops with a system clock that's wrong will think the certificate's expired, stuff like that. One thing we'd like to ask vendors that make clients, have a way that you can configurably say, don't prompt the user to install a new certificate. I would like a way to configure the client to say, if you see a certificate you don't know about, just pop up a box, tell the user, unknown certificate, you cannot associate, so as to defeat man-in-the-middle attacks for the users that don't understand what that means. So one of the big issues we have is accounting with 802.1x. Some vendors don't even support it, others implement it really poorly, and if you don't have accounting, you can't tell who was on. So you'll have authentication, but you'll never be able to go back and figure out who did this to you when you need to go track them down. So RFC 2866 tells us that there should be a unique accounting ID under this account session ID radius attribute. A start and stop record is going to have a matching pair, and it should uniquely identify it from that particular NAS. So a lot of vendors do this wrong. They will use the same record for everything, so it's impossible to distinguish. They'll use client MAC addresses, which is totally useless. Something that would be better would be a random integer that's unique, so that if you have the NAS IP address and the account session ID, that pair will be identifying a unique session at all times. Here's a couple of examples. Chime in here anytime. Cisco, these are a couple examples from Cisco access points and or wired switches that also support 802.1x that do this in a pretty good way. This first example, it's kind of verbose with the date and username. It has this unique value you can see there. That works. They send that same thing back on the account stop. So it works fine. This lower example here, the 1878, that's the way that Cisco 1200s often send their account session ID. That works well too. As long as you send the same thing in the start and stop and it's unique, it doesn't really matter as long as you can match on it.
Yeah, one of the problems here is that Proxim actually sends back the client's MAC address in every start and stop record, which is really useless because you then can't tie a start to a stop. And if they come out of order, then you're not going to be able to tell how long a user was on for a given session. So that's something that we would like to see vendors do a little bit better.
Called and calling station ID. This is what they should be. If they're set to something else, change them, please. The MAC address of the NAS that's authenticating the user should be the called station ID. The calling station ID should be the MAC of the supplicant or the client. A lot of vendors do this wrong, or they exclude it completely. A few other things we'd like to see: NAS port and NAS port type, the authentication type, the SSID they're associating to. Cisco does this pretty well in VSAs. It'd be nice to see that standardized perhaps so that other vendors can do it and it'd be easy to have some interoperability. Another issue is anonymous identities with a tunneled EAP type like PEEP or EAP TTLS. The outer identity is often anonymous, and then the inner identity has the real username. The idea is that if you don't have access to the encrypted data, you can't tell who the user is, but it makes accounting hard. So you might have to do a hack, like send back an access accept with the real username, hoping that the accounting data will have the real username in it. Some devices will do that. Others, you might be able to enforce that the clients set things up so that the inner and outer identities are the same. You can do that in Radiator with a simple hook. So, quick summary for people trying to deploy 802.1x. Second to last slide.
Use radius accounting. It's helpful. Consider creating a package installer for the end user. It makes things a lot easier. Several products let you do this. Make your users verify the certificate, the service certificate, with your CA or with a global CA, so that you can prevent man-in-the-middle attacks. Pick an EAP type and decide on whether or not you're going to use WPA or WPA2. Rotate your keys if you can. We know that WEP is not secure, so dynamic WEP with rotatable keys is a pretty good idea. And then we actually, at the University of Utah, is putting together an AP requirements list that people might be interested in. It contains a lot of information on what APs that we've tested support and what they don't support. We're only putting data up that we've actually tested and been able to get working, so that's something you might want to look at.
All right, this is it. We've already talked about a lot of these things. Don't filter EAP types, don't use the peer key, don't force WPA on, do accounting if you're a vendor, use the right account session ID, do the right thing with called and calling station ID. One thing, even Cisco, although they do a really good job on accounting, could do a little bit better on. The wired and wireless accounting formats totally different. It might be easier to make them the same. And client vendors, it'd be nice if you had some better debugging, so if you're not going to associate for some reason, tell us why. That's it. Questions?
Have you given much thought to fast, secure roaming issues with TTLS and ways that you would like that to be improved?
Yeah, I can comment about that a little bit. There's definitely some latency issues, especially if you're talking about a voice application or something. Doing the full build-up of the TLS tunnel back to the radio server via 802.1x takes some time. There's some proprietary solutions out there, such as Cisco has some solutions with sharing the key between the APs, but I don't think there's anything that's really good interoperability-wise.
802.11i actually has some pre-authentication abilities, and you might want to look at that. Basically, I don't really understand it a lot, but what I've heard is you can actually pre-authenticate to any access points that your client will see, so that if you jump, you're on.
Is this one live? I'll ask over here. About how many access users do you see authenticating to your radius? Do you have hundreds, thousands?
We've had thousands. Let's see, last year I think our stats were, in the library alone, which is the department I work in, we had 3,000 unique users, so it's quite a lot.
It's been hard for me to convince my user support organization that this is a good thing, because the captive portal is so dang easy to use. And so one of the things that we're trying to do is explain to them the security issue. They understand viruses, and so they understand those are bad. And so this is the next step in sort of doing something proactive. So the other problem that we have is that right now our APs can only broadcast one SSID. And so it's going to be not till first quarter next year that we can broadcast our 1X SSID alongside our captive portal SSID. So it's hard for users to see. And a lot of clients, if there's a broadcast and a non-broadcast SSID, will only associate to the broadcasted one, especially Microsoft clients. It can be tough to configure, so that makes it even harder for the users.
Thank you very much. That's a very good presentation.